The power grid is not as straightforward as simply running a line from the power plant to your home. A crucial part of the transmission process is the substation. Its main function is to safely and reliably deliver electricity to users by converting voltages. The substation is primarily composed of transformers, switchgear, circuit breakers, protective devices, and other auxiliary equipment. Among these, the transformer is the most essential component. Its main role is to change the voltage. Electricity generated at power plants is typically between 10 and 30 kilovolts. To reduce energy loss during long-distance transmission, the substation increases the voltage to several hundred kilovolts or even higher. However, once the electricity reaches the consumption area, the voltage is too high for direct use, so it must be reduced to a level suitable for users through the substation. But how does the substation manage this process of increasing and decreasing voltage? It all relies on the principle of electromagnetic induction. By setting different numbers of turns in the two coils of a transformer, the voltage can be adjusted. For example, if the input coil has 1000 turns and the output coil has 100 turns, the output voltage will be 1/10 of the input. Conversely, if the input coil has fewer turns and the output coil has more, the voltage is increased. It's important to note that this voltage transformation applies to alternating current, AC, because the transformer's operation depends on alternating magnetic flux. Direct current, DC, cannot be directly transformed by a transformer. As a key part of the power grid, the substation controls multiple independent transmission lines. Even if one line fails, the grid can still operate. The connection and disconnection of these lines are controlled by switches installed on bus bars. When the grid experiences a short circuit or fault, circuit breakers safely handle high voltages and large currents. When the voltage reaches a certain level, even air can become a conductor, meaning that the electric arc created by opening the circuit can still keep the grid electrified. To solve this, circuit breakers are filled with insulating oil or dense insulating gas to extinguish the arc and quickly control the current flow. For transient faults, such as lightning strikes or contact with trees, the automatic recloser in the substation will activate. It briefly disconnects the current and then restores it to test if the fault has cleared, all without human intervention. Substations are usually the only places where ultra-high voltage transmission lines come close to the ground, so they use multiple safety measures. All connections and equipment are fitted with large insulators to prevent ground arcs. There are also cement walls between devices as insulation barriers, and a grounding system underground. If a fault occurs, this system can channel the high current into the ground and trigger circuit breakers to trip, ensuring the substation continues to operate safely.